This is the second video of Akula TPU principle. In the video 1, I gave input through here, and then I saw the output from there, output from this white cable. It was number 1 video. And in the number 2 video, I'm gonna give into this white cable, this direction, input. And then this will be output, and there will be another output which I made by filler because it's 2 wires, and I saw by filler output as well. And last time I showed only the time domain, but this time I'm gonna go with the frequency domain first. First, it's nothing is going in. It's I would say it's a noise. And what is interesting is the frequency response from around 10 megahertz. It could be, I don't know, it could be 9.5 or 9. It's around 10 megahertz. And now is the number 1, just output here. This is the just a second. This is the output, and then the red probe will show the output, and this is the input. Okay, now 10 kilohertz given square wave. By the way, it's a square wave, and then I am growing. Okay, so its noise input is has about 100 megahertz response. Now I'm giving the input. As we see, there is a tendency. There is a tendency always wants to make this. And then I'm going to higher frequency. And 650 kilohertz is given. Around here is still, it doesn't change. It doesn't change. I think this is the ferro resonance frequency, which the Akula was saying. Anyway, I'm going. It's 1.3 megahertz. Yeah, there is a tendency always here wants to rise. So it's like that. And then I am now 3 megahertz. Yeah, 3 megahertz, 3.3 megahertz. And then I'm going 4 megahertz. Still, there is a tendency. This is the frequency. Before we talk about the extra energy, we have to understand why the ferro resonance is making this frequency. Now is the limit of the generator. What I'm gonna do is to show that that was not because of the LC resonance or anything. I'm gonna put extra capacitor in between the inputs. Okay, this extra capacitor is here. So if it is because of the input LC resonance, then it should shift or make it disappear or anything. Actually, it's making stronger the output. Again, I put extra capacitor in between here, but the output has a stronger response, even stronger response at 10 megahertz or 9 point something megahertz. Now I'm going down. Input is now 4.3 megahertz, and then 3.6, and then going down 2.7. Still, we can see the tendency here. It's always there, around 10 megahertz. It's interesting. Now I'm going to, again, 0. Input, I think it's a noise generation with capacitor. Now I'm going to the number 2 bifilar. To make the bifilar, I am connecting end here, and then this and this are connected. So this and this are connected through here, and then the red probe is going to measure the frequency response. As we see, although we make the bifilar, it's still there. And then I'm going up, the frequency is now 600, nearly 1 mega, and then 1.5, and then 2.4, 3 megahertz, and then it's nearly close to the limit of this function generator. But there is another interesting thing with the bifilar output. Input is a square wave. Again, input is a square wave. The bifilar output has something really interesting in the time domain. Now we are going to the time domain. The yellow probe is generator current, input current. Why I am saying this is not to avoid the LC resonance because of the generator. So, but what we are seeing is phenomenal because its output is great amplitude. Output amplitude is quite big, and then this frequency will not change. This low frequency will not change. So it's about 220 kilohertz. Okay, now its input is 4.7 megahertz. I'm going down. Going down, 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 down. Yes, this fluctuation frequency doesn't change. It's really interesting. And then now it's increasing the current. Yes, increasing the current and then increasing the amplitude of the output. Yes, I can understand that's the LC resonance area. But now we are going away from the LC resonance, but this frequency doesn't change. Again, here some looks like LC resonance, but doesn't change. Yeah. And then the low frequency here is something which I cannot understand yet why it increased so much, because the input didn't consume much. And this is 250, which showed this ripple around here without consuming much current. By the way, the output is square wave, 5 volt, peak to peak square wave. Without consuming much current, output is exploding. Yeah. I have to go down. And again, so around here, I don't know if it is LC resonance, but at least the input energy is not more consumed, and the output is increased. Yeah, this part. And then again, because it's interesting, I'm going up and up and up. Yeah. And then the area that makes the distorted form is because of the shock wave going to the ferrite. And I need to think about it, or I need to get some advice from the audience of this video. Okay, I'm going up. Then the square wave is made. Output is square wave from the bifila. And then it's going up. Yeah, it's the input resonance is here, LC resonance. That's the current is maximized. Input current, yellow probe is input current is maximized. Yeah, it's like that. Now the square wave is gone, and then now it's going close to the sine wave because of the capacitance is disturbing. Okay, now I'm going to connect again in between the input, this capacitor. Okay, although I put the capacitor, this wave is still alive. So low frequency is still alive. Okay, that's it.